Okay. So a thread is something else you have to actually understand in order to begin reverse engineering. At least not in the first year. You're probably going to be doing CTFs. You're going to be learning and stuff. So you're not going to have much work to do with threads. But anyways, threads are also important with reverse engineering malware and stuff. Doesn't just have to be hacking, whatever. So this is in the context of the Windows OS, but it's pretty similar. It's pretty similar all around. And a thread is basically an entity which the process, or sorry, in a process that the OS schedules for execution. Now, threads are actually the most basic unit of instruction. I should say within, but anyways, within a process or system. And without threads, our process will be unable to execute or actually do anything. It's a better way to say that. Not execute, but actually do anything. Now, the reason for this is that threads are a sequence of instructions, right? So you can think of C code. You have your main function and then two other functions that add two numbers and then come back. You can think of that as a thread, but it's far more complex than that. And every single thread on your computer actually has its own context. Now, what that means is you can think of a thread as one big bubble, while sure it is a sequence of instructions that the OS executes. Um, each thread has actually a copy of the context of a set of CPU registers that represents the set of the processor. So that could be kernel, user mode. Each thread on your process actually has two stacks, one for kernel mode and one for user mode. So, for instance, has to when your process has to render something to the screen, you're printing something, or it's OpenGL library, you're putting something on the screen. It has to go all the way down to the lowest kernel level instruction and execute that. So in order to do that, it has to actually switch to kernel mode. And your thread switches, for instance, your thread could switch to kernel mode. This is your process mostly, but I'm just trying to give an example. And if your thread needs to make for instance, if it needs to make I'm not sure, a kernel call. For instance, there's a thread local storage for use by runtime libraries. If a kernel runtime library is using that, then your thread executes code in that kernel section. So you can just think of it as, okay, I need to do something very low level. I'm going to do it in kernel mode. Something user level, I'm going to do it in user level. And I just said what a TLS is. And a thread ID just uniquely identifies that thread. Now, threads can also have their own security context. In Windows, they actually do. So, or they can, sorry. So a multi-threaded server application, so it's handling multiple user logins. There's multiple users accessing different client files all across the server. If a server wants to respond to that client, it would have to impersonate the security context of that client to serve that client information, because the user could just request something that doesn't belong to them, if that makes sense. So I want you to again to think of it as a sequence of instructions, but it is far more complex than that. And threads, the sequence of instructions that have their own context and could run in kernel mode or user mode, um, are basically the basic unit of instruction on your operating system for Windows more specifically. But again, same with most operating systems.